Which of the following represents the least stable conformation of 3-methylpentane if we are looking down the C2 to C3 carbon bond? So that tells us that we are looking for a Newman projection if we're looking down a bond, and it tells us that the front carbon is C2 and the back carbon, so this is going to be the front of our Newman projection, and the back carbon of our Newman projection should be C3. So if we are looking for the least stable conformation, we have two general frameworks to consider. So we could have a front carbon and a back carbon where everything is spread out, and that is our staggered conformation. And so typically we're looking at our staggered conformation as being the more stable conformations. And if we were to rotate the back carbon atoms, so we start having these bonds lining up or eclipsing each other, that is the eclipsed conformation. So we can think we spin this around, and now that carbon's kind of directly behind, or the bond is directly behind one another here and here and here. So this is the framework for the eclipsed Newman projection, and these are always your less stable conformations. And that's because these electrons are interacting, and electrons, remember, repel each other. So they want to spread out in the staggered conformation. Okay, so we're definitely looking at an eclipsed conformation. So I would say definitely not A or B, because those are your more stable staggered conformations. And so we want to look at C and D. And so let's look at 3-methylpentane. So this is a 5-carbon atom chain. All right, so there is our 1, 2, 3 with the methyl group, 4, and 5. So this is our carbon 2, and this is our carbon 3. So this is what we want to be the front of that Newman projection, and carbon 3 is what we want to be the back of the Newman projection. So essentially what we want to do is think about how bad can we make these interactions. And the worst thing that we could have happen is the largest group on carbon 2 overlapping with the largest group on carbon 3. So if we have our largest groups eclipsed, that would be the least stable conformation. So on carbon 1, that largest group is a methyl group. And on carbon 3, you've got a hydrogen, a methyl, and an ethyl, and so that largest group would be the ethyl group. So if one of these structures has the methyl eclipsing with the ethyl, then that would be your least stable, because you've got your largest groups eclipsed. Okay, and in case you're wondering, the most stable would be ones where we've got our larger groups kind of spread out as much as we can. So here we've got a lot of those gauche interactions. Here we've at least got this ethyl group not being next to, or not having all of these alkyl groups in a row, these 60-degree interactions. So this would be the most stable in case you were asked that problem.